So these are the things that we learned before. Constructing and analyzing a hypothesis test for the mean. When sigma is given, you're using Z. Remember our wallpaper? This is your first column. What is alpha? Standard test statistic Z. Find the area, find p-value, and if p is less than or equals to alpha, reject the null hypothesis. If p is greater than alpha, we fail to reject the null hypothesis. Page 3. Example. In auto racing, a pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. So it's very important. A pit crew claims that, well, a pit crew claims that, we're talking about the claim, it's mean. So one by one, we are identifying everything. The mean pit stop time for 4 new tires and fuel is less than 13 seconds. So circle these important keywords. Claim, mean time, less than. Mean, less than, mean, less than. Is it your null hypothesis or is it your alternative hypothesis? Which one is given here?
Alternative.
Very good. Alternative hypothesis is given because it just says less than. So mu is less than 13 seconds, which is given in this example. So as a statistician, you can quickly construct your null hypothesis, which is the opposite of less than. It's greater than or equals to 13. And note that this is the claim. Mean is less than 13 seconds. This is the claim. When a random sample of 32 pit stop times has a sample mean. So what is 32?
N.
Is N. Excellent. The sample size. Sample mean of 12.3. What is this 12.3?
Mean.
Which is?
Mu.
This is your sample mean.
Mean.
Sample mean. Is it mu? X bar.
X bar.
X bar is 12.9. Assume the population standard deviation is
Standard deviation.
is
19.
0.19. So this is your sigma.
Sigma.
Very well. Seconds. Is there enough evidence to support the claim when alpha is 1%? Okay, let us go to the board. Write these steps on the board. Step by step. So what information do I have here for this example?
X bar and mu.
Oh, one by one. In this example,
First,
I have my n, which is 32. What else I have? X
bar
is 12.9. I have sigma, which is
0.19.
990 or 19?
19. 19. 19.
19. Thank you so much. Okay. So the first step, is n greater than equals to 30?
Yes.
Yes. Step 1, n is 32 and greater than equals to 30. You're happy. Step 2, which case is your hypothesis testing here?
First one.
Very good. It's first one. Why is that? Because it says the mean time is less than 13 seconds. HA is given, mu is less than 13 seconds. H naught, mu is greater than or equals to 13 seconds. Well, what is the level of significance? Alpha is?
Alpha is 0.01.
1%. Excellent. Excellent. Now we have to move on to 4.
The standards tested.
Statistic, which is z equals to x bar, 12.9 minus mu. What is mu?
Mu is 13
seconds divided by sigma
0.19.
0.19 times square root of n
39.
32. So please do the calculation. Find z value for me. What's your z value?
Negative 2.9.
Minus 2.9.
Very good, very good. Thank you, everyone. Negative, it's approximately negative 2.98. Very good, excellent. Thank you, Nan. Thank you, Sunny. Excellent. Thank you, Vanessa. Perfect. Well done. Let us stop the class. I'm waiting. Thank you, Emily. Excellent. Well done. Well done. Thank you, Vijay. Thank you, Elaine. Thank you, Marvin. Shana, thank you. Max, thank you so much. Everyone, perfect. Excellent. Well done, everyone. Jessica, thank you so much. Well done. Well done. Perfect. Very well. So what is the next step? Find the area for Z. What is the area for Z?
Normal CDF.
Okay. Very good. We're going to use our calculator. What do we get? What is the area? 0.00146. Very good. Thank you, Nan. Thank you there. Thank you, Selena. Thank you so much. So the area, very good. Thank you there. Excellent. It's going to be 0. Thank you, Marvin. 0014. This is your area. Area to the left of Z. Okay. 6. What is the p-value? This is your first case.
1%.
The p-value is the same as your left area. 0.0014. The same. Because this is your first case. Then it's first case, p-value is equal to the area to the left, and we found the area to the left, which is 0.0014. Next step, You have to check these two cases. Is p-value less than or equals to alpha? Is p-value greater than alpha? If p is less than or equals alpha, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So which case is this? 0.0014. Is it less than or equals to, what was your alpha? Where is alpha? Alpha is 1%. Is it less than 1%?
Yes.
Yeah.
Yes. So p-value is less than or equals to alpha. It means that we reject the null hypothesis. So let's go over our document camera. Okay, perfect. So since sigma is given, that's why we can find z. Remember that. It's exactly the same as confidence interval that we did before. Since sigma is given, we use z. If sigma is not given, we have to use t. T is for 7.3. So because sigma is given and it is 0.19, the sample is random and n, or the sample size, is greater than or equals to 30, you can use the z test. The claim is the mean pit stop time is less than 13 seconds. So the null and alternative hypotheses are as follows. The null hypothesis says mean is greater than or equals to 13 seconds, and alternative hypothesis says mean is less than 13 seconds. And note that this is the claim. The level of significance is 1%. We found it here. The standardized test statistic is, we have to follow our nice formula, z equals to x bar minus mean divided by sigma. Since this is the second denominator, you can flip it and multiply by x squared minus mu. So you can rewrite z, standardized test statistic, as x bar minus mean divided by sigma multiplied by square root of n. We plug in the information that we have. X bar is 12.9, mu is 13, sigma is 0.19, and n is 32. We plug them in and we get an approximation negative 2.98. Using z table or using our calculator, we can find the area to the left. So let me clear that. Second verse, normal CDF. The lower limit, let us just plug in a negative number, negative 100. The upper limit is negative 2.98. So negative 2.98. Mu is 0. Standard deviation is 1. Since you're using our z table, this is a z. That's why your mean is 0 and standard deviation is 1. Let us paste, do the calculation. And as you can see, we get the area to the left side as 0.0014. This is the area, this is this little area here to the left side of your z. This is a very small area. And since p-value or the probability is the same as this area that you found here, to the left side of Z, p-value, very small area, is less than your alpha, 0.0014 is less than equals to alpha, 1%, it means that we reject the null hypothesis. It means that there is enough evidence that at 1% level of significance to support the claim. What was the claim? The mean pit stop time is less than 13 seconds. So we can support it. Let us move on to next page. Page 4. What do we have on page 4? Hypothesis testing using a p-value. Just zoom a little bit. Let's read the question carefully. According to a study, the mean cost of bariatric weight loss surgery is $21,500. $21,500. What is this? What is this number? We know that it's mean. It's mean. Is it X bar or is it the mu?
Is the mu?
It's mu. Very good. Why is that? Because we don't have information about sample. It just says according to a study. So this is your mean of the population. You think this information is incorrect. So it says, read it carefully. It says the mean is 21,500. The mean is 21,500. Is it your null hypothesis or alternative hypothesis?
Null hypothesis.
Null hypothesis is, remember that is was one of the keywords. So the null hypothesis says mu is equal to 21,500. So let me write this a little bit to the other side, avoid any confusion. So what is your alternative hypothesis? Mean?
Is not.
Is not
Equal.
Excellent. Excellent. Which category is this?
Third.
Third category. Excellent. The third category. It means that if we graph it, it's a two-tailed graph. A little bit of area is on the left, a little bit of area is on the right. Okay, let us continue. You think this information is incorrect. So as a statistician, what are you going to do? You're going to randomly select a sample, 25 bariatric surgery patients. So what is 25? Very well. Excellent. 25 is N, the sample size. Thank you, Sunny. And find that the mean cost for their surgeries is 20,695. What is this number?
X bar.
X bar. Thank you so much. Well, From past studies, the population standard deviation is given as $2,250. Sigma is given to you, and the population is normally distributed. Well, is there enough evidence to support your claim that the information is incorrect when alpha is 5%? So what is our N? N is
25.
25. Thank you so much. What is our X bar?
20,695.
695. What is your sigma?
It is 2,250.
Thank you very much. What is your N? N is 25. Is it greater than or equals to 30?
No, but it's a normal distribution.
Very good. What population is normal? So we're happy about that. What is our null hypothesis? Null hypothesis?
mu equals 21,500.
21,500. And what is your alternative hypothesis?
Mu does not equal 21,500.
Very good. Excellent. Thank you so much. What is your alpha?
0.05.
5%. Excellent. This is your level of significance. Now we have to construct our Z or standardized test statistic. So it is equal to, what is X bar? X bar is 20,695 minus the mean. What is your mean? What is the mean?
21,500.
Very good, 21,500. Divided by sigma, which is 2,250 times square root of 25. Please do the calculation. Find Z for me. Z is approximately. Very good. Thank you, Sunny. Negative 1 point. The rest of the class, what is the Z? Very good. Thank you, Adna. Thank you, Jessica. Negative 1 point. Thank you. Thank you, Nan. Thank you, Myra. Excellent. Thank you, Minha. Vanessa, excellent. Vijay, excellent. Thank you so much. Thank you, Emily. Perfect. Edgar, excellent. Thank you so much. Violet, excellent. Nice work. Marvin, thank you. So it's approximately negative 1.79. So what is the area for your Z? To the left side of Z, what's the area? The area is approximately what would be the area? It's almost area to the left side of Z. Very good. Thank you, Sunny. Excellent. 0.0. Thank you, Shauna. Thank you, Adnan. Perfect, Nan. Thank you so much. 0.036. Okay, perfect. So in the best case scenario, you can say that, hey, my area is, let's see, 4%. Not, let's stick to this. 6, what is the p-value? P-value, what's that probability? Remember that. This is this case, the last case, the third category. to find the p-value, you have to multiply left area by 2. So if I multiply 0.036 by 2, what I get? Perfect. Is it less than equals to alpha? Is it greater than alpha? Which case is this? Is P less than equals to alpha? Is P greater than alpha? It's almost 7%. Your alpha is 5%. P is greater than alpha. So this is this case. P, or 0.072, is greater than alpha, which is 0.05. What's the meaning of that? It means that we fail to reject the null hypothesis. Fail to reject the null hypothesis. This is our conclusion. So let us take a look at our document camera. These are the information that we have, and our detailed solution is, because sigma is given, it's known, and it is $2,250, and the sample is random, and the population is normally distributed, you can use the z-test. What is the claim? The claim is that the mean is different from 21,500. Why is that? Because you think that this information is incorrect. This is the claim. You're a statistician and you say, hey, I don't think this information are correct. So the null and alternative hypotheses are as follows. Null hypothesis says mean is equal to 21,500, and alternative hypothesis says nope, it's not. And this is your claim. The claim is your alternative hypothesis. Well, we're given the alpha or level of significance, which is 5%. The level of significance is 5%. Your job is to construct the standardized test statistic, which is z equals to x bar minus mean divided by sigma times square root of n. As we did these calculations, we got z almost negative 1.79. Okay, this is your z. Z is negative 1.79. You want to find the area to the left side of z. So you look at your calculator, turn on the calculator, clear this, second bars, normal CDF. On the left-hand side, you get negative 100, for example. On the right-hand side, on the upper side, you have negative 1.79, negative 1.79, and then 0 and 1, paste. This little area to the left is 0.036. You can add more decimals as you want. So this is approximately 0.0367. This is this little area to the left. But note that here you have the exact same area to the right. So p-value is the sum of these two areas, or just multiply one of them by 2. So your p-value is equal to 2 times this little area on the left-hand side, which gives you 0.0734. This is your p-value. Now, you have to check to see if p-value is less than equals to alpha or p-value is greater than alpha. If p-value is less than equals to alpha, you reject the null hypothesis. If not, if p is greater than equals to alpha, you fail to reject the null hypothesis. Which case is this? P is almost 7%. We have our alpha to be 5%. 7% is always greater than 5%. So we fail to reject the null hypothesis. We fail to reject the null hypothesis. We fail to reject the null hypothesis. Because the p-value is greater than alpha, you fail to reject the null hypothesis. What's the meaning of that? You say, hey, there is not enough evidence at 5% level of significance to support the claim that the mean cost of bariatric surgery is different from $21,500. 25 patients and the mean. And the mean of this sample is 2695. It means that this is your X bar.